One engine feature designed to save fuel is quietly destroying engines across America. If your car has it, internal components are wearing faster than they should, often without symptoms until catastrophic failure happens. By the end, you'll see which engine technology mechanics refuse to buy in their own vehicles, despite manufacturers installing it in millions of cars. But first, you need to understand what this feature does and why the engineering trade-offs are causing failures that weren't supposed to happen for another 100,000 miles. Here's the feature: cylinder deactivation. It goes by different names: active fuel management at GM, multi-displacement system at Chrysler, variable cylinder management at Honda. The concept is simple. During light load conditions like highway cruising, the engine shuts down half its cylinders. A V8 becomes a V4, a V6 becomes a V3. Fuel economy improves. On paper, it's brilliant. In practice, it's creating wear patterns destroying engines between 80,000 and 150,000 miles. We analyzed failure data from thousands of engines, interviewed mechanics who've torn down failed cylinder deactivation engines, tracked warranty claims across manufacturers. The problems aren't theoretical. These are real failures happening to real vehicles across every climate. Owners think they're getting reliable engines with bonus fuel economy. What they're actually getting are engines with accelerated wear, oil consumption, and expensive failures. GM 5.3 liters and 6.2 liters, V8 with AFM. Start with GM's active fuel management system in the 5.3 liter and 6.2 liter V8 engines. These engines power millions of vehicles: Silverados, Sierras, Suburbans, Tahoes, Yukons, Escalades. The AFM system is designed to improve fuel economy by deactivating 4 cylinders during cruising. The problem is lifter failures. The AFM lifters have additional components, solenoids and internal mechanisms that allow them to collapse. These components fail between 80,000 and 150,000 miles. When AFM lifters fail, they can destroy camshafts, damage valve springs, and in severe cases, send metal debris through the engine requiring complete replacement. But here's what makes AFM particularly insidious: the failure progression. It starts with a slight tick or knock at idle. Owners think it's normal. The noise worsens gradually. By the time it's obviously problematic, internal damage is done. The camshaft lobes are worn. The lifter bores are damaged. You're not looking at simple lifter replacement. You're looking at camshaft replacement, lifter replacement, and potentially cylinder head work. Repair costs run $4,000 to $8,000. The oil consumption compounds the problem. AFM engines develop excessive oil consumption between 80,000 and 120,000 miles. Some engines need a quart every 1,000 miles. This oil consumption is caused partly by the AFM system cycling cylinders on and off, creating oil control issues. Owners who don't check oil frequently run engines low, causing accelerated wear. Here's the cruel reality: GM knows about these problems. They've issued technical service bulletins. They've made design changes in newer engines, but they haven't recalled the millions of vehicles with problematic AFM systems. Owners discover the issues after warranty expires and face expensive repairs. The repair costs are severe: full AFM delete, replacing lifters with non-AFM lifters, replacing the camshaft, installing an AFM disable kit costs $3,500 to $6,000. If you wait until failure and need additional cylinder head work, costs reach $8,000 to $12,000. On trucks worth $15,000 to $20,000, those repair costs are devastating. One owner in Texas bought a 2012 Silverado with the 5.3 AFM engine. At 95,000 miles, a slight tick appeared. His mechanic said it was likely AFM lifter issues starting. At 108,000 miles, the tick became a loud knock. Diagnosis: failed AFM lifter, damaged camshaft lobe, metal debris in the oil, complete engine teardown and rebuild quoted at $9,200. The truck was worth $16,000. He faced a repair costing over half the truck's value because of a fuel-saving feature he never asked for. But at least GM's AFM problems are well documented. The next manufacturer's version is newer and surprising people. Honda 3.5 liters, V6 with VCM. Honda's variable cylinder management system in the 3.5 liter V6 engine seemed like brilliant engineering from a brand known for reliability. The system deactivates 3 cylinders during light load, improving fuel economy. It's installed in Accords, Pilots, Odysseys, Ridgelines, millions of Honda's most popular vehicles. The problem is excessive vibration and wear. When the engine switches between 6-cylinder and 3-cylinder mode, vibrations increase. Honda tried to manage this with active engine mounts, but the constant cycling creates wear on engine mounts, transmission mounts, and internal engine components. But here's what makes Honda's VCM particularly problematic: the piston ring wear. The cylinders that deactivate experience different thermal and pressure cycles than the continuously running cylinders. This creates uneven wear patterns. The deactivating cylinders develop excessive oil consumption first. Owners notice oil consumption starting around 80,000 miles and worsening progressively. The spark plug fouling compounds the issues. The deactivating cylinders can develop carbon buildup and spark plug fouling because they're not running hot enough to burn off deposits during deactivation. This creates misfires and poor running conditions. The transmission issues emerge from the constant cycling. Honda transmissions paired with VCM engines experience accelerated wear because they're constantly adapting to the engine switching between modes. Transmission shuddering and premature failure rates are higher in VCM-equipped vehicles compared to non-VCM versions of the same models. Here's what frustrates Honda owners specifically. They chose Honda for reliability. The VCM system betrays that expectation. Owners who've owned multiple Hondas without issues suddenly face oil consumption, engine mount failures, and transmission problems, all tied to the VCM system they didn't want and can't easily disable. The repair costs accumulate over time. Engine mounts fail every 60 to 80,000 miles, $800 to $1,200. Transmission shuddering requires fluid changes and potential internal work, $1,200 to $4,000. Oil consumption requires constant monitoring and top-ups or eventual engine work, $5,000 to $10,000 for serious repairs. One family in California bought a 2014 Pilot with the VCM 3.5 V6 specifically for Honda reliability. At 72,000 miles, they noticed increased oil consumption, about a quart every 1,500 miles. At 88,000 miles, the engine mounts needed replacement, $1,100. At 96,000 miles, the transmission started shuddering. Dealer quoted $2,800 for transmission service and fluid flush. At 105,000 miles, oil consumption had increased to a quart per 1,000 miles. They faced either constant oil top-ups or major engine work. The Honda they bought for reliability was problematic specifically because of the VCM system. But Japanese manufacturers aren't the only ones with cylinder deactivation problems. Ram 1500 5.7-liter Hemi with MDS. The Ram 1500 with the 5.7-liter Hemi and multi-displacement system seemed like the perfect truck. V8 power when you need it, V4 fuel economy when you don't. The MDS system deactivates 4 cylinders during cruising. The problem is the lifter and camshaft failures mirror GM's issues. The MDS lifters have additional mechanical complexity. That complexity creates failure points. Between 80,000 and 140,000 miles, MDS lifters begin failing. The failure progression is similar to GM: ticking noise, then knocking, then catastrophic failure with camshaft damage and metal debris. But here's what makes the Hemi MDS particularly expensive. The Hemi engine's overhead cam design makes repairs more labor-intensive than GM's pushrod V8s. You need to remove cylinder heads to access the camshafts. Repair costs for failed MDS lifters and damaged camshafts run $6,000 to $10,000. The exhaust manifold bolt failures compound MDS problems. Hemi engines have a separate, widespread issue with exhaust manifold bolts breaking. When combined with MDS problems, owners face multiple expensive repairs simultaneously. Exhaust manifold repair is $1,500 to $2,500. Add MDS failure and you're looking at $8,000 to $12,000 in repairs. The oil consumption issues emerge similarly to other cylinder deactivation engines. Hemi MDS engines develop oil consumption between 90,000 and 130,000 miles. The consumption is caused partly by the cylinder deactivation creating oil control issues. Here's the frustrating reality for Ram owners. The non-MDS Hemi engines are significantly more reliable. If you could buy a Ram 1500 with a 5.7 Hemi without MDS, you'd have a durable engine. But most models came standard with MDS, and owners can't easily opt out. The resale market is learning. Used Ram 1000s with the MDS Hemi are selling for less than equivalent Toyotas or Fords because word has spread about the MDS lifter issues. That depreciation hits current owners trying to sell before facing expensive repairs. One owner in Colorado bought a 2015 Ram 1500 with the 5.7 MDS Hemi for towing and daily driving. At 98,000 miles, a ticking noise appeared. At 107,000 miles, the tick became a knock. Diagnosis: failed MDS lifters, damaged camshaft, cylinder head removal required. Quoted $9,800 for repair. Additionally, the exhaust manifold bolts had broken. Another $1,800. Total repair bill: $11,600 on a truck worth $19,000. The MDS system that was supposed to save fuel was costing him over half the truck's value in repairs. But at least American V8s have reasonable parts availability. The next one combines cylinder deactivation with German complexity. Mercedes-Benz 4.7-liter V8 with cylinder deactivation. Mercedes-Benz implemented cylinder deactivation in the 4.7-liter twin-turbo V8, calling it Eco mode. 4 cylinders deactivate during light load. The problem is system complexity creates multiple failure modes. Solenoids fail. Control modules develop faults. Turbochargers experience accelerated wear from constant cycling. Each component failure costs thousands at Mercedes dealer labor rates. You can't repair these engines at independent shops easily. Diagnostic equipment is Mercedes-specific. Parts are expensive and dealer-only. A failure costing $4,000 at an independent shop costs $8,000 to $12,000 at Mercedes dealers. The oil consumption is severe. Some engines need a quart every 500 miles. Mercedes considers this within spec, leaving owners constantly buying expensive synthetic oil. Carbon buildup compounds all issues. Direct injection combined with cylinder deactivation creates severe carbon on intake valves. Cleaning is necessary every 40,000 to 60,000 miles at $800 to $1,500. One owner in New York bought a 2012 Mercedes ML with the 4.7 twin-turbo E COV8. At 68,000 miles, oil consumption became noticeable. At 79,000, carbon cleaning, $1,200. At 92,000, cylinder deactivation solenoids failed, $4,800. At 103,000, turbochargers showed wear, quoted $9,500. Between oil consumption, carbon cleaning, and 2 major repairs, he spent over $16,000 from 68 to 103,000 miles. But at least Mercedes engines have some performance. The next one sacrifices reliability for minimal gains. Cadillac 6.2 liters V8 with active fuel management. The Cadillac 6.2-liter V8 with active fuel management powers luxury SUVs, Escalades, XT6s, and performance sedans. It's essentially GM's AFM system in a luxury application. The problems mirror the GM truck engines, but with luxury-level repair costs. The AFM lifter failures occur at the same mileage ranges, 80 to 150,000 miles. But repair costs at Cadillac dealers are significantly higher than at Chevrolet dealers for essentially the same repair. AFM delete or failure repair costs $6,000 to $12,000 at Cadillac dealer labor rates. But here's what makes the Cadillac application particularly problematic: the customers. Escalade buyers pay $80,000 to $100,000 for vehicles and expect luxury reliability. When AFM lifters fail, they're shocked by both the mechanical failure and the repair cost. The cognitive dissonance of paying luxury prices and getting reliability problems creates intense customer dissatisfaction. The oil consumption is identical to other GM AFM engines. The symptoms are the same, but Cadillac owners are less likely to check oil regularly. They expect luxury vehicles to be maintenance-free. Running these engines low on oil causes accelerated wear and increases failure rates. The resale values are suffering. Used Escalades with high mileage are selling for less than expected because buyers research AFM problems before purchasing. A 5-year-old Escalade approaching 100,000 miles might need an $8,000 AFM repair soon. That knowledge depresses values. One owner in Georgia bought a 2017 Escalade new for $92,000. At 112,000 miles, the telltale AFM tick appeared. His Cadillac dealer diagnosed it as early AFM lifter failure. The quote, $10,800 for complete AFM delete, camshaft replacement, and cylinder head inspection. On a vehicle worth $40,000, that $10,000 repair was devastating. He'd paid for luxury and received a ticking time bomb, but luxury American brands at least have wide service networks. The next one is rare and expensive to fix. Volkswagen 1.4-liter TSI with a CT. Volkswagen's active cylinder technology in the 1.4-liter turbocharged engine seems like smart engineering. A small, efficient engine with cylinder deactivation for maximum economy. 2 of the 4 cylinders deactivate during light load. The problem is multiple systems failing simultaneously. The turbocharger experiences accelerated wear from constant load changes. The engine mounts fail prematurely from increased vibration. The dual-clutch transmission has trouble adapting to the constantly changing engine characteristics. But here's what makes the VW-ACT particularly problematic: parts availability and cost. The 1.4 TSI isn't common in America. Parts can be hard to source. When components fail, you're often waiting weeks for parts from Germany at premium prices. The carbon buildup is severe. The 1.4 TSI uses direct injection. Combined with cylinder deactivation creating cooler running conditions in deactivated cylinders, carbon accumulates aggressively. Carbon cleaning is necessary every 30 to 40,000 miles in these engines, more frequently than non-ACT engines. The oil consumption develops earlier than in larger engines. The 1.4 TSI with ACT can start showing oil consumption at 50 to 60,000 miles. By 80,000 miles, some engines need a quart every 1,500 miles. One owner in Illinois bought a 2016 Jetta with the 1.4 TSI ACT for fuel economy. At 58,000 miles, carbon cleaning was necessary, $950. At 69,000, the turbocharger failed, $3,200. At 76,000, oil consumption had increased to a quart every 1,000 miles. At 84,000, the engine mounts needed replacement, $800. Total repair costs over 26,000 miles, $5,750 on a car worth maybe $8,000. The cylinder deactivation that was supposed to save fuel cost him thousands in repairs. Look at the pattern across all these engines. Cylinder deactivation improves fuel economy on EPA tests, maybe 1 to 2 miles per gallon in real-world driving. But that minor fuel savings comes at enormous cost in reliability and longevity. The fundamental problem is mechanical complexity. Cylinder deactivation requires additional components: special lifters with solenoids, complex control systems, sensors monitoring constantly. Each additional component is a potential failure point, but complexity isn't the only issue. The operating conditions created by cylinder deactivation accelerate wear. Cylinders cycling on and off experience different thermal loads than constantly running cylinders. This creates uneven wear patterns. The oil control issues from cylinders deactivating and reactivating cause consumption problems. Manufacturers knew these trade-offs existed. They chose fuel economy numbers over long-term reliability because EPA requirements and CAFE standards forced their hand. They needed efficiency targets. Cylinder deactivation met those targets while allowing them to sell vehicles with larger engines. The owners pay the price. They're buying vehicles thinking they're getting reliable transportation with bonus efficiency. What they're actually getting are engines needing expensive repairs between 80,000 and 150,000 miles, right after warranty expires. The repair costs often exceed fuel savings. If cylinder deactivation saves $500 yearly in fuel, but costs $8,000 to repair at 100,000 miles, you've lost money. Mechanics refuse to own these engines in their personal vehicles. They've seen too many failures, torn apart too many engines with damaged camshafts and failed lifters. When mechanics who fix these vehicles daily won't own them, that tells you everything. If you already own a vehicle with cylinder deactivation, you have options. AFM/MDS delete kits are available for GM and Chrysler engines, replacing problematic lifters with solid ones and disabling the system. This costs $3,500 to $5,500, but prevents $8,000 to $12,000 catastrophic failure. For Honda VCM engines, VCM muzzler devices trick the system into staying in full cylinder mode. These cost around $200. Frequent oil changes help, every 3,000 to 4,000 miles instead of manufacturer intervals. Most importantly, monitor oil consumption religiously. Check oil every 1,000 miles. If consumption exceeds a quart per 3,000 miles, you're developing problems. Address them before catastrophic failure. If your car has cylinder deactivation, AFM, MDS, VCM, or any variant, internal components are wearing faster than they should. From GM's widespread AFM lifter failures to Honda's VCM oil consumption, these fuel-saving features create expensive problems emerging right after warranty expires. If this changed how you think about engine technology, hit that like button. Drop a comment with your cylinder deactivation engine experience. Real ownership data matters. Subscribe for automotive truth about real-world reliability of modern engine technology. Hit the bell because the next video covers which engine technologies actually deliver without creating reliability nightmares.